All right, it says Gisela, I guess that's how you say that, computed 342 times 23 as follows. Okay, so you can tell she broke it down into place values and then combine like terms. Knowing by combine like terms, she adds the diagonals here. Okay. You say, well, how can she add 120 to a 40? That's not tens. Well, it's actually 12 tens as per 120. So that's how you can do that. Can you explain what she's doing? Well, that's what I kind of just did. She just multiplied all the place values by each other and then combined like terms. So 300 times 20 is 6,000. And then 40 times 20 is 800. And here's 2 times 3 is 6. Okay. And of course, you did 2 times 20 here, 40 times 3, and 300 times 3. And this combine like terms. Okay. Now, to actually get the final answer, you would have to add all of these together. So that would be 7,700 plus 166. So 7,866. Okay. We're going to use geometric diagrams to compute the following. So that's exactly what they're wanting you to do. Just use the boxes there to do it. Now you can simply do distributive property. That's what this is. This is just using some fancy boxes to do it. So 3x squared times 2x would be 6x cubed. And we'll go across the top. 3x squared times, 4x times 2 squared is 8x squared. 2 times 2x is 4x. Now 3 times 3x squared is 9x squared. 3 times 4x is 12x. 3 times 2 is 6. And then we got to combine these terms. So we're going to have 6x cubed plus 17x squared plus 16x plus 6. Okay. I think earlier they just wrote these out to the side here, but I didn't want to do that, so I'll do that now. 6. Okay. So this should be squared. All right, same thing for this one here. 2x squared plus 10x plus 1. All right, x squared plus x plus 1. Get smaller right here because I don't have enough room. Maybe we can do it. This one's easy. Let's do the quick ones right here. Okay, these ones are just simply going to be what's to the side of it. So this is going to be here. This will be 2x squared. That's got those. Now we got to add an x here. 2x cubed. Oh, actually, that's to the 4th because it's squared right here. Look that too far over here. And this one would be 2x cubed. And then 10x to the 3rd. 10x squared. Okay. And then combine like terms. So we got 2x to the 4th. Remember, you combine like terms on the diagonal. That should line up correctly. Plus 12x cubed. 10 to 13 plus 13x squared plus 11x plus 1. Okay. Another one. I just put my bigger polynomial on top, just because that's how I'm used to doing it. So, all right. This is going to be x to the fourth, x to the third, 6x to the third. That's a negative x cubed. Negative 6x squared, negative 5x, and positive 5 now. So, combine like terms, we're left with x to the fourth plus 5x cubed. And then here, notice we don't have anything to add to the squared. This is by itself, so minus 6x squared. This x is by itself. And there you go. Now multiply the polynomials using distributive property. So we have to do each one by each term. So 3x squared times x to the fourth is 3x to the sixth. 3x squared times negative 2x is negative 6x cubed. 3x squared times 1 is plus 3x squared. Now you have to do all these. So we're going to have x to the fifth, negative 2x squared plus x. And then we have to, so basically we're just negating all that because that's just a negative one. Minus x to the fourth plus 2x minus 1. Now combine all these like terms. Well, I don't have as many as I thought. 3x to the sixth. Get rid of that. Next one, you want to go in descending order. So the next one's the fifth, so plus x to the fifth. Get that out of the way. Now you got x to the fourth. Next one. Now, negative 6x to the third. And we can combine these two. 3 minus 2 is 1, so we're just left with x squared plus, here we go, we got 3x and minus 1. Okay, so this is a polynomial. Notice that the sixth degree, so you would say that this polynomial has 6 degrees to the 6th degree polynomial. Okay. It says the expression 10x squared plus 6x cubed is a result of applying distributive property to the expression 2x squared times 5 plus 3x. It is also the result of applying the distributive property there and there. For example, even to, okay, so it's just giving you different ways to come up with 10x squared plus 6x cubed. Now, I'm going to write it down in expression such that it is applied distributive property to your expression. It would give the results, give interesting answers, it says. Okay. All right. So we got 6a plus 14a squared. So you want to say, what can I factor out of these? Well, I know that both of those are even, and both of them have an a. So I can factor out 2a. What's 2? 6a divided by 2a is 3 plus 14a divided by 2a is 7a. Okay. You can always go to the highest degree that all the terms have. So on B, all of them have x 4 and above. So I know I can factor out x to the fourth. And all of them are even, all of them are 2's actually. So I could actually factor out 2x to the fourth. I'm left with 1 plus x 1/6. If you do distributive property, you will end up with that b there. Okay, let's keep going. Okay. Both of those 6c squared minus 15c are all they're multiples of 3. So let's go with 3z since both of them have a z. Now these are not very common. I mean, not very common. They're not very what I say, interesting. And I'm just trying to make sure you all know how you can factor out here. So 42w cubed minus 14w plus 77w cubed. I think 7 will go into all of those, and w will be in all of those. So let's factor that out. Same thing as dividing. What's 42 divided by 7? 6. W cubed divided by w is w squared minus 14 divided by 7 is 2. W divided by w is 1, so we don't have to put it. Plus 77 divided by 7 is 11. W to the 5th divided by w is plus 1, or w to the 4th, sorry. W to the 4th. So there would be your factor there. E. Okay, this one's pretty neat. This one, all of them have a z squared, and all of them have an a plus b. So you would say all of that times 1, because that's just that first term, plus z oh, don't want that. Let's do it a different way. Now you can say z squared plus z cubed times a plus b. That's what I wanted to do. I like that better. You can just take these two terms. So this would kind of be like the associative property, kind of grouping them differently. Right. All we have here is a half that we can factor out. So how many halves are in 3 halves? 3s squared plus 1. Because 1/2 divided by 1/2 is 1. Okay. Oh my goodness. This one is. Can we factor something out of all of them? Well, we know we can factor out p squared and r squared. They're all multiples of 3. So let's go 3p squared r squared. And if we do that, 15p cubed r to the 4th would be 5p r squared minus 6p squared r to the 5th divided by 3p squared r squared is going to be minus 2 r to the 3rd plus 9p to the 4th r squared divided by 3p squared r squared is going to be 3p squared, and then plus 3 square roots of 2p cubed r to the 6th divided by 3p squared r squared is going to be square root of 2p r to the 4th. And that should have everything out of all those terms. Okay. H.4x to the 9th minus 40x to the 8th. I'm just going to take the easy route on this one and say x to the 8th times 0.4 x. Sorry, I don't want to do that. Minus 40. That'll work too. Few more. How we're going to factor something? Okay, so these both have this common binomial, so we can factor that out of both of them. Okay, and then you're going to have to write down your 4x plus 3 minus 2x plus 2. All right. The next one. What can we factor out here? Okay, I'm going to factor the z squared, or not z squared, but z minus 2. We're going to factor it out. We're just moving it around here. And then minus I can do 13 times z minus 2 z minus 3. Okay, so then I can factor, since now I have this term, I can rewrite this as z minus 2 times 2z minus 15, not 15, minus 5 minus 13 times z minus 3. Whew. Okay, that was not that pretty, but that'll work. Sammy wrote a polynomial using only one variable, x, of degree 3. Misha wrote a polynomial in the same variable of degree of 5. What can you say about the degree of the products, or of the product of Sammy's and Misha's polynomial? Since we're multiplying, we both have x to the 3rd and x to the 5th. whenever you multiply those, you should have x to the 8 as your degree of polynomial. Right. And that looks like that is it for your homework, or for the classwork, which is now going to be your homework.